Well, good morning to all. Hopefully everybody had a fun night and a good plenary session and learned all kinds of stuff. Now you're ready to learn all about emerging technologies. In this particular case, optical gas imaging. So these guys are online over here, huh? They are. So Ram is going to be giving this presentation from a Teams link up, and Ram's been around for a long time. He's a international expert in the development and implementation of optical remote sensing and other advanced air monitoring methodologies. He is the co-inventor of the radial plume mapping method, which is an EPA other test method 10, and the optical remote sensing for emission characterization of non-point sources. And this project, which was performed under Ram's direction for both public and private sector clients, advanced methods have been used to measure gaseous and particle emission from sources as diverse as landfills, concentrated animal feeding operations, wastewater treatment plants, chloroalkali plants, refueling stations, military aircraft, fugitive dust from military activities, open burning, barges, on road or near road mobile sources, agriculture operations. There's a big old long list here, and I'm not going to go through every one of them, but we'll pick a few more. Get coke oven batteries and chemical manufacturing. And so here, with no further ado, his methods have also been applied to the emergency response, as well as for human health and safety applications and advanced air monitoring solutions, especially fence line monitoring and fugitive source emission monitoring for greenhouse gases and air toxics. So with no further ado, is Ram online? You go, boy.
Yes, it's me and Ilan Waldman from OPGAL. We are online.
Okay, can you hear us? Can everyone hear us?
You over. To the right.
Yeah, just that one. Turn it all the way up. Can you try speaking again real quick?
Yeah, can you hear us?
That's better.
Yeah.
All right. I don't know if you can see us. We have the video going as well. I don't know. We can't see you.
Yeah, we have the presentation up.
Yeah,
All right,
you're on you're on a slide that says optical gas imaging recent innovations on this, and we can see you in the upper right hand corner. So you can't
All
see
right,
it,
great.
we can see you.
All right, so we'll start. So thank you for joining us. Good morning, everybody. Unfortunately, we couldn't be there this year, so we're doing the presentation online. We'll try to go as quickly as possible. We have a couple of additions that we've added as well to our products that we want to announce. So we'll get started. So my name is Ilan Waldman, and I'm the sales director in OPGAL, and Ram got the introduction previously. He was here beside me as well. So just very quickly on OPGAL, for those of you who don't know who we are, we've been around for over 40 years developing thermal imaging for the defense industry, for the security industry, the last 10 years or so, also for the industrial applications as well. We are owned and backed by Elbit Systems, and as of last year, OPGAL is now strictly concentrating on optical gas imaging solutions. So we no longer manufacture anything that has to do with defense or security. We're strictly concentrating on optical gas imaging solutions. So we have handheld cooled cameras that we have right now, our uncooled handheld camera as well. We're working on our 24/7 fixed solutions and our OGI quantifications, amongst other things that we'll announce at the end of the presentation as well that we're working on. So we're not going to go through why OGI, what are the advantages of OGI, because by now it's recognized pretty much worldwide as the most efficient technology for emission reduction. But you know, the last couple of years we've been thinking, we have the camera, it's a great camera, and what can we do to improve the camera performance, and more importantly, what can we do to make the field inspection faster and more efficient using our OGI technology. So this is our Icy Gas Mini. This is our uncooled camera. For those of you who are familiar with the uncooled OGI technology, you're aware that there's many limitations to the camera. Mostly, it's a methane camera, medium to large leaks only. Our Mini is compact, it's light, but it's got its limitations. It can detect approximately 10 grams an hour. So like I said, it's pretty much large leaks, and you have to have a very, very good delta T as well. We're working right now on trying to improve the uncooled technology. It's not close to cool technology yet. I don't think just ours. I think any other uncooled OGI camera is not nearly as effective as the cool technology. We are working on it, but right now this is the camera that we have. One of the main features in the camera is the automatic gas detection mode, which is colorization of the plume on top of visual of the application. So this is our Icy Gas 2.0. This is our cooled OGI camera, and this is the camera that we've had some nice additions lately, and another couple additions that we're going to announce today. This camera detects methane in over 400 VOCs. It's got a patent replaceable filter as well. It's the only OGI camera where you can actually change 3 different filters in the same camera and can detect not just VOCs and methane, but also CO2 as well, all in the same camera. It's very sensitive. It can detect 0.35 grams per an hour, where our Mini, the uncooled camera, is 10 grams per an hour. So it shows you the difference between uncooled and the cooled technology. It's, of course, EPA Quad Away compliant, intrinsically safe. It's got a built-in GPS. It's got a built-in memory card, so you don't need to stick in the memory card, stick it in and out. You just connect the camera to your computer to download the images and to download the videos. We've integrated third-party analyzers and LDAR software to the camera. So if your company is using the TVA 2020, RMLD, or any other analyzer, we could integrate that into the camera so you can detect with the camera and have a reading on the screen, the reading of the product, of the third product on the screen, as well as LDAR software. The camera doesn't require any cables, so you can stream the visual of the camera to your phone, to your tablet, via Wi-Fi. You can also transfer the images and the videos to your tablet or your computer or your laptop via Wi-Fi as well, so you don't need to connect a cable into your computer. And then we offer free firmware upgrades. So every 6 months or so, we have additions to the camera, like one that we're going to announce later today. And anyone that owns an Icy Gas 2.0 will get that addition for free. So you don't need to purchase a new camera. All of our customers that have the Icy Gas 2.0, each time we have a new addition to the camera and a new feature, they get it for free. So we'll just go now through some of the highlights. The Gas 2.0. On. We got some technical issues. Go to this one. Go.
Okay, I'm Ram Hashmonay, Chief Innovation Scientist here in OPGAL, and one of our unique feature is that we have replaceable eye filters that we can match the spectral range of the camera to the application. If we are measuring from close by or far away, or for specific group of compounds, we can replace in a couple of minutes the filter and optimize the detection to the application. So this is the kit that comes, that you can take off the lens and unscrew the filter and screw the new filter, do one press button of calibration, and you're ready to go in a couple of minutes with the new filter to match other application. So these are the three filters. We show here the spectral range of the whole OGI camera from 3.1 to 4.3, and we can fit here the blue curve on the left is the filter, is the transmission spectrum of the filter, the standard filter that comes with the camera. We have a long range filter. This is the green one, 0.1 micron to the right of it. And I'll talk about this feature in a second. And the third filter that we're going to replace here is the CO2 filter, that we can use the same camera to measure CO2. This is around 4.2 to 4.4. This is the absorption of CO2. And you can see that this is on the edge of this camera. Detection is slightly less than the dedicated optimized camera for CO2 that we have also in OPGAL, but you can still, for many applications, detect CO2 with the VOC camera that we have. This is only one camera, just replacing the filters. What you can see here, this is the absorption of methane, octane, and propane on these two filters. So, and on the light blue on the left lines are water vapor lines. So you can see that water vapor lines overlap the standard filter. And this is all OGI, cooled OGI cameras are approximately in the same region between 3.2 to 3.5 micron. So every OGI camera has the same issue of water vapor. This is negligible when you're talking about close range detection. This is not reducing your thermal contrast when you use it from close range. But if you're talking about long range and you're looking on the sky background, this could make a huge difference, because water vapor are either absorbing or emitting energy and obscure or interfere with your detection. So you can see here our standard filter can cover all of these hydrocarbons, VOCs, methane, propane, and octane. And you can see that the long range filter, which is the green one to the right, to the longer wavelength, 0.1 micron to long range, is almost free of water vapor. Therefore, it will work better on long range. You can see this is the standard filter, and this is, I'm sorry, sorry. You can see here that this is the absorption of hexane, and hexane fit better on the long range filter. So the heavy alkane are better detected with the long range filter. But also, when you're looking at the long range, I will ignore this equation at the bottom. My next presentation in room 400 will go deeper into the equations. But right now, what I want to show, you cannot ignore the interference of the absorption of water vapor. And for some reason, it's not moving. Just a second, there is a delay.
Right click, check the right click. And next.
No.
No.
Okay, so these are two images. We are looking at a plume at a tank farm from 500 meters. There is a big leak on the left side of this tank. These are the same images, but the two filters. The image to the left is the long range filter. You can see the leak much more clearly. You can see the mountain range in the background. You can see a gradient on the sky. Over here, around 500 meters, the temperature of the sky and the temperature of everything in the image are almost the same temperature. And this is because it's a hot, humid day in the summer in Israel near the seashore. Humidity is very high. The absolute humidity is very high. And the sky temperature is very high. So it's very hard to see leaks from far away when you're using the standard filter. We have the opportunity to replace the filter and optimize the application when we look at leaks from far away. This is an example from 6 miles, 10-kilometer venting rig at a startup. It's intended, and this is an all-day emissions, and this is a Skybacker, and we use this 3.5, even though it's natural gas and methane, it's not very optimized for the gas, but for the distance, it gives us much better results than the starter filter because we get the gradient of the sky. This is the January 6th. It's a winter, and this is a fast-forwarding all-day emissions. These are huge emissions. I will go a little bit faster here. You can see around the afternoon, we can see a white plume, and then the black plume, it's when the sunset and the sky temperature is now colder, and then we see a black plume, white plume turn into white plume. But the point here, this is a 10-kilometer away venting that you can see with our long-range filter. And this is a unique feature that we have in our camera.
Okay, we'll move on now to some things we've added recently. So we've integrated the ICGAS 2.0 recently to the RealWear eyepiece. So this really gives an added feature to our camera and gives the inspector an easier time. What you can do is you virtually put on the eyepiece connected to the camera, and you remote live stream the camera feed to the eyepiece. So you can virtually control the whole camera from the eyepiece via voice command, just like Alexa. You can zoom in, zoom out, change palette, start recording, stop recording, save images, literally do everything all from the eyepiece. And it enables you to also hold the camera in different positions. It enables you to reach areas which are usually harder to reach if you had to stare at the screen or wear the headpiece as well. So this is one of the additions that we've added recently. You can see this in our booth right now if you want, or after the presentation. Another thing that we've added is we've created the ICGAS app, which is a dedicated app to the ICGAS 2.0, and it enables you to stream the camera feed to your phone via the app. You can do it also with VLC as well, but this is a dedicated app, and you can control the whole camera from the app. So you can place the camera on the tripod and just control the camera from your app. Zoom in, zoom out, very similar to the eyepiece, but just with a phone. And if you're a couple of people out in the field and someone wants to see the camera feed as well, then one person can hold the camera, the other one can see everything from the phone as well. It saves all the images and videos on your phone, and you can share them via SMS, WhatsApp, email very easily and fast without having to connect the camera to a computer and download them. So those are two things that we've added recently. We'll talk just quickly on the IC site now, Ram.
Yeah, this is our quantification tablet that we released more than a year ago. It's called the IC Sight 2.0. It's a wireless, the tablet is wireless connected to the computer. We can use this software also in post-analysis mode. I will show you a movie in a second, but we can collect a special type of data that we call OGI data files that we can collect it on the camera and then download it through Wi-Fi to the tablet or to a desktop computer and do the analysis at the end of the day or whenever we would like, and do some changes in the analysis and get optimized results. So we don't need the tablet in the field. We can collect data on the camera and do the analysis in the end of the day or in the end of the week. So this is the procedure. This is a short movie on the procedure. You have the ICGAS tablet. You find the leak with the ICGAS camera. Once you find a leak, you can take out the tablet, connect it wirelessly to the camera. The camera will be on a tripod. we cannot do the analysis without a tripod, and going through 6, 7 screens where you optimize the location of the leak on the image, and you can color the plume. You determine the air temperature, wind speed, distance. It's like a wizard in the software, and after half a minute, you can press enter and get the results within a minute of starting the process. So we have a unique feature here of reporting. It's automatically save the data in Word format, Excel format, and we are still in the process of optimizing the report structure to the client needs. Our unique software has been QOGI software has been evaluated in several studies and found to be the most accurate QOGI software in the market. These are the screens you can see here. We can put the air temperature, we choose the compound, we choose the distance. And Ilan, I'll let you.
So we decided in the beginning of the year that in order to allow our customers to enjoy the most up-to-date technology, we're including now the IC-Sight QOGI either as a tablet or as a software on your laptop or on your computer virtually for free with every IC Gas 2.0 purchase. So everyone who purchases a camera in 2023 will also get the IC-Sight for free. So this is very exciting. We're very excited about it to be able to let all of our customers use this QOGI technology and ultimately to enhance the inspection. Even if you're not using it for QOGI, we have the colorization feature, which enables you to see smaller leaks a little bit better in the field. So this is something that we've added just recently, and you can, of course, find out more details on this in our booth. And one more thing that we've just added right now and is just being released and will be available in the next firmware upgrade to all of our customers and, of course, new customers is what we call Virtual Method 21. We've included where you will be able to I'll let Ram, do you want to get more information on?
You can put your camera on a tripod and aim the center of the image into the point that you want to quantify, and it will give you the ppm, not the ppm meters, not the integrated concentration, the ppm, average ppm through the plume. So it will be somewhat remote measurement of the average ppm in the plume at the point at the center of the image. So this is a new feature, and this is only the beginning because we are adding to this feature probably in a couple firmware upgrade. We will have the all quantification in fluxes, in gram per hour or cubic feet per hour or per minute. We will have all the units quantification in the camera. So we're starting with evaluating the concentration and the maximum concentration in the plume during the measurement, and the measurement will be recorded on the image. As you can see here, it will give the reading on the screen, and it can be recorded with the video what were the concentration of the leak detection event.
So anyone, just like all of our updates, anyone who owns IC Gas 2.0 will get this for free via a very simple firmware upgrade, and of course all new customers as well. So this is not something where you need to go out and purchase a new camera. This is available to all of our existing customers and will be available to our new customers as well.
Okay, another new addition is that we're working for several years. We're working on our continuous monitoring 24/7 OGI And we did a couple of pilots or installations with a different approach, both in uncooled and cooled cameras. And if you can see, the camera on the left is our older generation cooled camera that we're looking on a tank farm for 6 months. And yes, we detected many leaks, but when you detect a leak with the OGI camera, it's really depend on the atmospheric conditions and the distance. So we couldn't, some big leaks that were far away, we could not see, and we could see some small leaks that were close by, and the time of the day, night, day, dusk, dawn, has a huge impact both on detection and also on the quantification. It was almost impossible to get our head around it, and we decided that we need to find a new approach when we do the continuous monitoring. So we decided to begin with our cooled camera technology. That's what we are doing, and do some firmware changes. And we added another thermal channel to eliminate false alarms. And we have here the visible camera, and we have the camera on a pen and tilt. And the new idea, we are looking at emission at the site level. We are actually scanning, instead of scanning the whole sites in a routine manner and all the potential point of sources, we are scanning the boundary of the site. We are trying to see if something significant is crossing the fence line. And we are aiming it on the fence lines, and once we are aiming, we have a definite detection. If both cameras, both channels over here are responding, we know it's not gas, because only one is an OGI camera. And if we see the response of the plume is on one camera, on the OGI camera, we know this is gas. So we have a definite detection of an event. We also use these two channels to more accurately quantify the concentration, the average concentration along the fence line in a screen of beams, a screen of pixels. That's why we get like a vertical plane. And we actually, with wind speed and wind direction, we actually quantify what is the flux of gas crossing that boundary. And then once we know that, we also do some triangulation to estimate where is the area within the site that we can see the plume coming from, where the source. And only then we aim the OGI camera, try to color the plume or I went through everything. So we quantify how much on the fence line, and then we do some triangulation with wind speed and wind direction, trying to figure out where is the area, where it's coming from, and then we aim it. And you can see this is some animation to show we are checking on the boundary, and then we triangulate the area. We have the ROI, and then we're trying to image where specifically which tank it's coming from. So this is a whole system. We began with a cooled camera for big sites. Can go up to 1 kilometer on one side of the site, but this same approach can work very nicely with the uncooled on a smaller site, like well pads or much smaller sites. Then this is refineries. The cooled camera is more suitable for big tank farms, refineries, and compressor stations that are more than 200 meters on one side. But the same approach can work with the uncooled camera.
Okay, so just before we finish up, we just wanted to give you a little bit of a spoiler of where we're going. So, and what we're working on in the next few months, hopefully even a little sooner. So regarding QOGI, we're improving the accuracy through better wind assessment algorithm. In addition to shorting the data collection to 10 to 20 seconds, where now you need to wait approximately a minute to get the quantification, we're hoping soon it'll be 10 to 20 seconds. We're grading the scene for quantification while setting up the collection and analysis as well. Regarding the Icy Gas 2.0, we'll be improving the quantification features into the Icy Gas 2.0 camera. And we're adding an OGI camera for drones as well. It'll be Icy Gas OGI for drones, in addition to quantification from the drone as well.
And I want to add something about the 24/7. We are in a stage of finalizing the development of our new approach of the 24/7, and we are looking to partner with industry, environmental consulting company or integrators to do pilots to prove the concept and further develop the approach.
And that's it. Thank you very much.
Anybody got any questions for them? I think they can hear what we're saying.
Yes, we can hear.
Question?
Where can you find the app?
Where can you find, sorry, the hat?
The app for the phone.
So the app, right now, we don't have it up anywhere. It's an APK. So you can just contact me or contact one of the distributors and we'll email you the APK to download. We have right now, we have it available for Android. Very soon we'll have it for iOS as well.
Do all three filters come with the camera or do they have to buy them separate?
So the camera comes with one filter, the standard filter. You can purchase the two other filters separately, but they're very cost effective. They're not very expensive.
On your drone application, what platform are you putting it on?
So I don't want to go into details about the drone right now. It's still in R&D stage. We'll have hopefully in the next couple of months, maybe a bit sooner, hopefully not longer. We'll have a more finalized product, and then we'll probably do a webinar to announce it and to display it as well.
Our intention is to add also quantification from a drone, not just the camera.
Yeah. So the issue is not the camera. We have the camera. Not our problem. What we're working on right now is to be able to quantify with the camera from the drone. This is where we are right now, and we're hoping that in a couple of months we'll have that finalized.
For the 10-kilometer video, what was the focal length on that lens?
75 millimeters. We have another lens that comes with as an add-on to the camera, so it's 75 millimeters. I think one of the images was 2x digital zoom also, so you could see. Okay, like our standard lens is 30 millimeters. Okay.
No further questions? Everybody good? Going once, going twice? All righty, thank you guys for giving the presentation.
I'm moving to another
Next
room to
up,
400, talking about critical technical issues with Appendix K. So anybody who wants to see some graphs and equations is welcome.
They're all rolling out, man. They didn't hear that, so.
All right. Thank you.
I'm sorry?
I think we recorded the conversation, so if any of the attendees wanna view that, they'll have access to it. But thank you so much.
Thank you. Take care.
You take
Bye-bye.
care. Bye.
Didn't?